Hi guys, today we're going to be talking about functions. We spent a lot of time in algebra in ninth grade talking about functions, so we're just going to revisit it as part of this chapter 3 unit. So we're going to refresh our memories on domain and range and what it means to be a function. So we're going to start with vocab. A relation is a set of ordered pairs. For example, just give me a list of ordered pairs. 0, 1, 2, 5, 3, 6, 7, 8. The domain, they are the x values. So domain starts with a D, range starts with a R in alphabetical order. Domain is X, range is Y, so they go in alphabetical order. So it's the X values of a relation. So if we look at our example above, what were the X values? We use a capital D. We list the variable that we're looking at, X for domain, and then we just go through and pick out the X values. So we have 0, 2, 3, and 7. The range are the Y values of a relation. So the Y values of that set of examples, we do a capital R. 1, 5, 6, 8. We put them in order from lowest to highest. A function is a set of ordered pairs where any two ordered pairs do not have the same x value. So x values cannot repeat. So a set of ordered pairs where any two do not have the same x value. I'll just put pairs do not have the same x value. So let's make an example of what that might look like. So we could go with 3, 5, 4, 5, 6, 8, and 8, 8. So x values do not repeat, but the y values do, which is fine. So to be a function, no x values repeat. That's the big deal, or no domains. So there's another way to look at functions. It's by mapping them. So given the function 3, 0, 4, -1, 5, 0, and 6, 1, is this a function? So we go through, we look at our domains in the first. So 3, 4, 5, 6 are my domain values. We put our ranges in the second one. So look at the y values, put them from lowest to highest. So -1, 0, 1. Then we just map them. So we draw a line from 3 to 0, 4 to -1, 5 to 0, and 6 to 1. I look at my domain circle. Because there's only one line coming off of each value in the domain circle, it is a function. So yes, it is a function. Domains do not repeat. So not a function could be this one. So we have 0, 2, and 3. We have -6, 5, 7, and 8. 0 goes to 5, 0 goes to -6, 2 goes to 7, and 3 goes to 8. Because of these two lines coming off of the 0, that will show me that it's not a function. So we would write not a function. FCT is my abbreviation. Domains repeat. Does the diagram below represent a function? So we look at the x values. We check out these. Are there any repeats? There are not, so yes. Domains do not repeat. Go through and look at example 2. Is example 2, is that a function or not a function? So you're comparing all the x values in A. Do they repeat? No, they do not. So it is not a function. So yes. How about B? Do any of the domains repeat? I have a 1 and a 1. So that's no good. So this is not a function. We've already looked at function notation this year. It just happens naturally. So function notation is when we have a variable in a parenthesis, or a variable represented by a number in a parenthesis. So instead of using a y, they use an f of x often, or g of x or anything. So f of x is used to replace y. So looking at example 3, how would you go about solving that? So f of x equals 3x plus 4. Find f of 5. What does it want you to do? So because it says f of 5, it wants you to put a 5 where the x is. So all it means for the notation is replace the variable with the number in the parentheses. Then we'll simplify. So f of 5, if you want to keep the notation, you can, means 3 times 5 plus 4. 15 plus 4 is 19. We do not touch this side. Just keep it f of 5. You don't do anything with that side. It's just saying the function evaluated when x is 5. Then we can get a little bit trickier and not give you a number to plug in. So 19 minus 5. This is saying replace x with x plus 2. So when you do that, you need to put a parenthesis, x plus 2, distribute the negative, and combine like terms. It's basically just substitution. Domain, our x values are our input. Range are our y values or our output. So we already looked at it with ordered pairs. So with ordered pairs, x is the domain, y is the range. The other option is if you're given a function. FCT is my abbreviation for function. If you're given a function, you might have to plug in the x values to find the y values. So of course, we're going to look at this in a minute. Which will then give us the range. So when we're looking at our list of numbers, the domain is just the x values, so go ahead and list those. The range is just the y values. Go ahead and list those. So domain is x values, range are y values. So we have 1, 2, 3, 4, 5 for our x values. Good. How about your range? I see 1, 4, 10, and 13. Nice. Example 6 shows the other way. So for example 6, you're going to go through and you're going to plug in each value. So if you have a graphing calculator, you can use your y equals. If you don't have a graphing calculator, it's not a big deal. Again, if you have a graphing calculator, you would type this into y equals, type in 5x minus 8, and then you're just going to read your table at the values. So -3, -1, 0, 1, 3. If you don't, no big deal. It's not that much work to do this math. So we're just substituting in, we're solving. So we're doing each of these one at a time, plugging in. So -15 minus 8 is -23. -5 minus 8 is -13. 5 times 0 minus 8 is -8. 5 times 1 minus 8 is -3. And 5 times 3 minus 8 is 7. So our range for this is listing the y values. So -23, comma, -13, -8, -3, and 7. All right, you're going to go through and do you try it's here. So just listing the domain and the range. You're actually doing these, so if you're not listening to me and you just have those down, here you're substituting in the -4 for x. Here you're plugging in a 3h for x. Here you're substituting in each of these one at a time. And then undefined, that's probably the trickiest part of this lesson. They are the values excluded from the domain because they make the denominator 0. So values excluded from the domain. Remember, we can't divide by 0. That's what it means to be undefined. Because they make the denominator 0. So everything works for the domain except the values that make the denominator 0. So this takes a little bit of practice. So our steps: set the denominator is down, d is down, the denominator equals to 0. Solve for x. So we're going to set x minus 4 equal to 0. We get x equals 4. That means 4 is going to make this undefined. So our domain, we don't care about the top, is everything. We usually just write x cannot equal 4. So it's everything, but x cannot equal 4. It can be everything else. For this one, 3 can never equal 0. So this one is just the domain is reals. So everything works. Or you can write no. It says what values are excluded from the domain. So this one would just be 4 is excluded. And this is none. Everything works. All right, good luck. I'll give you some practice problems.